my God.
Now,
Okay, everybody needs to be serious because you didn't.
Serious business. Yes, YouTube serious time. All right, maybe I can stand out of the way a little bit. I'm Bart.
Hi, Bart.
Hi, Bart.
Hi. This is a little update on what's going on with HamWAN as of October 2014, a network you guys very graciously helped to fund. So I'd like to really help you for your support. That went a long way to let us implement several sites. All right, so here's the achievements I had listed for year one. I'm just kind of updating that presentation. Some of you might have seen. It was a really short 12-slide thing of everything that we did in year one and everything we hope to do going forward. So I'll give you guys an update and report of all of those aspirational things. So I'm not going to go over this all because that was already talked about. So here's everything that happened in year two though. So we have a brand new site. This is a really exciting thing. It's our tallest site at 4,100 feet. It's near Salton, Washington. It's a two-sector site pointing north and pointing southwest, because towards the east there's a big old Cascade Mountain range, so there's no sense shooting into a mountainside. It's also our first solar-powered site, so that was exciting. Solar does add to the cost of the site, as you might imagine. The panels aren't cheap. Actually, the panels aren't bad, but the shipping on the panels is really expensive.
Is it a daylight-only site then?
No, there's batteries. Yeah, we've got batteries to run for I think 2 or 3 weeks on just battery power.
Okay.
Yeah.
Did it double or triple the cost of the site?
Did it double or triple the cost? I think it doubled. Yeah. So it wasn't that bad,
It's
actually.
also nicely buffered.
And that was
For
just
weeks,
yeah.
it's nicely buffered. So.
Yeah, it's fully emergency ready because you're not reliant on utilities.
the extra cost was strictly the panels and the batteries, is that pretty much, and the regulators?
We didn't buy any batteries, so the batteries the site owners already had on site. They didn't have enough generation power throughout the winter though, so we added more panels.
Okay.
And then we added a charge controller because these panels are at a different geometry from the top panels, so they charge at different times. So we track the peak on our panel set, and they track the peak on their panel set, and we add the peaks together into the battery bank.
I see.
Okay, we also bought a beefier inverter because there's alternate power systems up there. There's what is it? A thermal electric generator. So they have a giant propane tank. It burns a little fire, and there's a bunch of little Peltier junctions around the fire with heat sinks that sink to the outside. And the temperature delta across those junctions generates a bunch of power that goes right into the battery bank. That's one way of generating power. They also have a gasoline generator on site that they can turn on remotely via microwave command, and it'll kick in the starter, and it'll suck some gasoline down and generate at a really high rate into the battery bank. So it's a triple redundant power system kind of situation.
Interesting.
But getting propane up there, getting gas up there is really expensive. So they really like to not use those resources, so they asked us for offsetting our energy costs. And instead of going with a monthly payment for their fuel, instead we just said we're going to do a one-time solar thing, and here's our extra generation capacity, and away we go. Okay, so it ended up being a free site in the long term. We did have capital costs up front though. Anyway, that's a lot of talking. Here's a coverage map of the site. Well, that's not going to happen, is it? Here, let me track this over there.
Presentation mode first.
Oh, there we go.
Nah. Oh, Jesus.
Oh!
Too many.
That's the data center, baby.
Okay, let's get
Looks
out of
like you've got help.
presentation mode. Let's drag this over there.
There we go.
Let's unbiggen that. All right. So the site is, I'll indicate with my pointer here. It's right around there. Okay.
Okay.
And that's the kind of 70 dBm power level you can expect throughout the Puget Sound area from it. Okay, so it covers a little bit to the north. You can see I've got some markers here.
Did Corey move?
Covers a lot of this. No, that's not Corey, that's Rob.
Oh, right.
Uh,
Corey's actually looking for.
So yeah, if you're in this kind of area, you know, this is
So you
not a
actually
bad
have
thing to
coverage.
aim at.
You got coverage for me on Union.
Here's my question.
Yeah.
I'm right in the middle of all of this hash.
Yeah.
What does that really mean? Because I'm sure it's not actually precise.
Yeah,
Right,
it's
so
not
based on
precise at
something
all.
like GIS.
It means if your property has trees blocking that direction, you're not gonna get anything, and if it doesn't, then you probably will get it.
And it just is that clean, right? So I'd have to figure out what the exact location is at 4,100 feet up, because I have no idea
So-
how to look at the mountains and
We
see
can
any
do, we can
intent.
do more specific pathing for your exact location
Mhm.
if you give us an exact height above ground,
Mhm.
so we can track
But
that
it's
very
the trees.
specifically.
Where's the I-90
That,
It's a quick, because I've got a view
Oh,
that's.
okay, well,
520, 900, there's the I-90.
Yeah. This is 202, so I've got a view which is sort of like this,
Yeah.
but I don't know that it goes up far enough.
Yeah.
And so I would sort of need to get the exact location and figure out the azimuth.
Right.
And that
And
good stuff.
really all the best modeling is only an assumption,
Mhm.
right? It doesn't model the trees, right? So you really have to just go out there with a kit and see if you can pick up anything at a specific location. You might have to move horizontally a few feet over to get a better signal. Anyway, so it's got really impressive coverage. It's got direct line of sight to downtown Bellevue, downtown Seattle. It can see across the water. So 6 gig, as long as you've got perfect line of sight, it'll just keep going. It doesn't care, you know, you've got great speed, but as soon as you start getting some trees in the way, then things get really, really dicey, so. But in terms of height and visibility from the site, it's just stupendous, so we spent a bunch of energy building this up. All right, so I'll stop talking about that. Let's get back to presentation mode. So in terms of other new things that have happened, new progeny instantiated. So this part of the project has been taking a bunch of time.
Where are your priorities, man? I don't get this. You get some messed up priorities.
yeah, what's going on?
No, she's great. So yeah, this has been a really great experience. And this is a very, very early picture of her. She's getting much, much bigger now. So anyway, so if you're wondering
We still have a
where,
chance of setting the all-time record for youngest ham licensee.
right?
The clock is ticking.
Yeah, gotta get her studying. Yeah.
Get that license going.
Yeah, so if you're wondering where my time's been going and why I haven't been as active as in previous years, you know, this is a big part of that.
Can you go back, sorry, just to your
You skimmed over a whole bunch of stuff.
Yeah.
Oh,
this is
right.
Memphis Metro, what is that all about? And-
Oh, okay, this point. So that, I don't think I got a copy of the video, but they actually took a video of setting up their first cell site down in Memphis. So they're covering a bunch of that area now. They're using the same standards that we are, so they're compatible with us. The networks are talking to each other, so that's all happy. Yeah, so that's a pretty big accomplishment from this year, is the fact that we've got another instance of HamWAN standing up somewhere.
where's
I like it.
Yeah,
So what, did you know about them? Did they come to you?
yeah. Well, we've been working with the main guy there for the last year, I think.
You're gonna build a link?
Oh,
VPN
not an RF
tunnels?
link,
Maybe.
but yeah, we've got internet stuff connected, so
Okay.
the two networks talk to each other.
Cool.
Yeah.
So the big one is number 5, from
Oh,
personally
I don't have a
speaking.
number. 1, 2, 3, 4, 5. Finish Capital
No.
Parks. Oh, for you.
Capital Park,
Right.
finally.
Yeah, so Kenny was out of service for a long time until we finally installed the last 2 sectors at that site. So that happened, and Kenny's online now, so he's all happy. We also got this Queen Anne site that's connected directly to the Weston building, which Tim's company is helping to provide some bandwidth there.
How
and
long is that
space.
going to work?
That's going to work until Amazon's building is about another 100 feet up.
Which is about 6 to 9 months.
Yeah.
Yeah.
Well, then we just link from Amazon.
And then we'll have some intermittent connectivity issues and we'll be going, what is going
And then it'll
on?
die. Yeah.
If we only had a contact at Amazon, if we only had one of those.
Can we find
I
something?
don't think he has enough clout to halt the construction.
Doesn't exist.
Way above my pay grade.
Doesn't exist.
What do you mean?
So
Oh, gosh.
it's not all on your shoulders. We do have another contact in Amazon that has apparently made some roadways into getting some roof space on that building. So I don't know if anything's going to happen with that. So we've got a backup plan. There's this new Tequila internet feed site coming up. So we've got approval from them. They've given us the contracts to sign. One of the requirements is getting some insurance together, and we need some other help in getting that whole site deployed. So.
So will Tequila sync back up with Baldy then? Did it link in?
Tequila will link with Baldy for sure. There's direct line of sight.
Yeah, okay.
I'm hoping it can link with Haystack as well, but it's going through a very thin layer of trees. Well, don't shake your head, you haven't looked at the path.
Okay.
There's one hill in the way, and we're going just through the peak of the hill, just the tiny bit of trees there.
So it might work.
And you can
So-
kind of see through them. You can see
Cougar's not in the
sky
way?
on the other side, but
Cougar's not in the way?
no, cougar's not in the way of Haystack. Haystack is way north. We can see tiger, so if we had a location on tiger, that would be an excellent relief from Tukwila.
So I have a chainsaw if you need to take care of a
That's
couple
right.
trees.
Chainsaws appreciated as well as muscle to actually do it. I can let you know the trees I have an issue with.
What would you be prepared to do to get a site on Tiger Mountain?
God, what do I have to do?
Well, I mean, because Mike and Key has a facility there. I'm an officer of Mike and Key.
Mike,
I mean,
he has a
yeah, one of
facility
their
up there?
Yeah, our, the K7 LED repair
Right,
is
so-
on.
Oh, that's Tiger West, right?
Let's just bring a dish up there.
I guess.
Plug it in?
I don't
Tiger
remember which Tiger.
I got the
Get in my car, let's go.
Okay.
Yeah, so let's talk about more of those details after.
Okay.
Yeah, because I haven't ever done a talk at Mike and Key, actually, oddly enough. I've done a bunch of little
I'm in
clubs, but
charge
I've
of
never done
scheduling
Mike
talks
and
at Mike and Key.
Key. Yeah. Okay.
Really only had a
That might be
There you go.
All right, and finally, the last achievement from year 2 was a bunch of discovery of what happens at 6 gig propagation throughout the summer, which is a completely different beast than throughout the winter. I think one of our topics for a couple of weeks was HamWAN, it works great in the winter, and it's totally true. I
My
was
signal
getting,
strength's gotten better in the last 2 weeks.
has it?
By
All the
2-3
leaves are
dBs.
going away?
Yeah, and then a couple months of improvement coming.
Yeah, it's just gotten better and better and better.
Makes sense, doesn't it?
So to Scott's site over there, to the snow dam, I was getting 95 megabit in the depth of winter, which is great. That's a fantastic speed. But during the summer, that same figure has dropped to maybe like 5 to 7 megabit.
What?
Yeah. So it's quite the hit because I am going through a hill,
You know,
so I'm crashing through a bunch of trees.
I worked for AT&T when I first started, and the guys were just coming back from Iran, and they could still go there.
Yeah.
And they were saying that in the heat, the microwave gets deflected up. It hits and deflects up, so
Yeah.
they have to put 2 dishes, one for the daytime and one for the one for
different
normal
focal
time.
points.
Because
Oh, right.
it deflects, and I'm wondering if that's not what you're hitting too.
Yeah, I could see ducting being an issue as well.
Especially because most
But we-
things are shooting around or through
Foliage.
or over the top of or
Ridges and
something.
everything, yeah. So you might
But
get some.
then again, it seems to me like most of the links that have actual clear line of sight are not affected by any kind of ducting phenomenon. They're pretty rock steady. So I kind of suspect ducting is not as big of an issue as the foliage coming up on
It might be
trees.
the proximity to the ground too. If there's a lot of air between it, then they're not going to do it because it's the ground that radiates the heat.
That's true. Yeah, our Baldy link is pretty high up above the ground, so yeah, it might not be affected by that temperature and layer.
You actually said Haystack's the highest site. Baldy, if you count where the antennas are on the tower, might be higher than the antennas at Haystack.
Baldy's tower is 60 feet.
Yeah, is the ground like 4,050?
It's just 4,000 flat. So it's 4,060 at the top of
Close
the tower.
race.
We need
Close
to get
race.
GPS measure.
Yeah, but it's down to feet.
GPS
And I
not
think
very precise.
Haystack wins out in this one, but we can have a pissing contest about it. That'd be cool.
I'll bring my barometer.
All right. All right. So this was HamWAN Labs last year, and I did a little bit of a talk about what all this stuff is. So I won't go over that again. So I'll talk about the new additions that are kind of exciting to this whole set of equipment. And I'm listing the prices here, and this is a really bad example to start with, but I'm listing the prices so you guys don't feel like this is completely unattainable. Okay, this one's really expensive and it's my worst example, but the rest of them I think you'll see are a lot more reasonable. So this is a vector network analyzer. You can do things like characterize circuits in much more detail because you get that phase information there. You can do some reflective analysis, through analysis and all that. It goes up to 6 gigs, so we can do everything that HamWAN does and everything below that. And a fair bit of dynamic range, so you can do really good filter measurements. And I'll talk about that a little bit more. There's an item right now on eBay, this item number, which is just a fantastic deal. The next up listed item for the same set of features or similar set of features starts at 7K. Okay, so 4.5 is a fantastic deal. So if you're
But you
into-
never buy the cheapest one on eBay.
It's listed as used. It's actually in Oregon. You could probably work with the company
Yeah,
for
if
some
you go down and
issue.
see it, that's what
Yeah,
I'll-
you can play with it before you get it. So if you're looking for a really good VNA that goes up to 6 gig, this item number is a steal of a deal right
I
now.
think it's.
Okay? Just wanted to point that out.
I want to know if it comes in a floppy.
And this is a sample of that VNA being used on a parallel LC circuit. So you get a pretty little circle on your Smith chart. You get your phase diagram right at the transition point right there. And I sent a challenge to my Google Plus feed about this a while back. Anyway, next thing up is vector signal analyzer. So this is not just for measuring electronic circuits, but this is like a communications analysis thing. So it can demodulate, decode, and tell you details about a bunch of digital modulations. So if you want to feed it FSK, it'll tell you about just how dirty your FSK is. And it can then decode your FSK stream. It'll give you ones and zeros and stuff. You can record them. If you want to decode CDMA, like from a cell phone, great. It'll do the, what's the thing called? It'll de-chip the signal for you, and then it'll start doing the other processing to decode CDMA. It does GSM, it can decode, Bluetooth. Oh, he walked out.
Yeah.
It can analyze Bluetooth directly. And it can also synthesize a bunch of these things. And it can also do arbitrary synthesis, so you can program the wave shape you want it to emit, and it'll just start sending it out. So you can do like beacon frames for whatever arbitrary modulation you feel like playing with.
So for $1,400, it's a software-defined radio that goes from DC to 2.65 gigahertz.
With a mixer, with a
Yeah,
big
yeah.
old mixer on the bottom. Yeah, but the software suite inside the software-defined radio is just incredible. I mean, you get little EVM diagrams, you get tons of flexibility, you get like waterfall displays if you want. Yeah, it's a really complicated instrument as well.
Floppy drives.
So that's only 1,400 on eBay?
Yeah.
Yeah,
Sorry.
That's what I was thinking.
So,
How much did you spend on all of your SDR
Did
stuff?
you see that? Did you see
probably
that sign
doesn't go
language
DC
just
to
now?
2.65
You said waterfall
gigahertz,
display. This
has
sign
a
language
floppy
control
drive.
display.
What?
This has a floppy drive.
Yes, it has a floppy drive.
yeah.
It's just dating itself a little bit, but that's adjuvant.
So did the previous
Okay.
one.
If we're gonna diss on these beautiful instruments. This is another thing, so I wanted to play with radar stuff a little bit because that was one of the goals. So this is called officially a digital communications analyzer, but really it's a really fast sampling oscilloscope. The module I bought for this goes up to 20 gigahertz, so you can look in the time domain at up to 20 gigs worth of bandwidth. And you can, I think these take up to 50 gig, I think is the fastest I saw. You can also feed it optical signals, so you can do fiber analysis if you're into analyzing your gigabit Ethernet or whatever you want to do. It wasn't all that expensive. The oscilloscope itself is $380, and the expensive part is actually the acquisition module, which was $900. Oh, I should point out the previous one, this was my acquisition cost at the time I bought it. Presently, the listings that I found were overpriced.
Do you buy these on eBay?
Yes, most of these.
What are you paying for shipping?
These prices are with shipping.
Oh, wow.
Yeah. And these ones are current eBay prices, right? So if you wanted to drop that coin today, you could actually acquire that for that exact price today.
So what is the instantaneous sampling rate on this?
The instantaneous.
Because you say, as you say, it works on repetitive signals only. That means the
Yeah.
sampling rate is for repetitive signal.
Right, it's a lower sampling
The ones
rate.
that real.
Yeah, it's not a real-time scope, so I
Right,
think
so the
it's.
question is, I mean, some of these things have really, really low
Yeah,
instantaneous
I think it's
sampling.
40 kilohertz.
Yeah, so it's
Yeah.
not unusual.
Yeah,
Right.
that's they
That's
only.
why it's not insanely expensive too.
Yes, if this were real time, it
That's
would
right.
be
That's right.
absolutely
It would be insanely
insane.
expensive.
Yeah, it would be insanity. It would, yeah.
Oh, so it's similar to like an array of caps, is that how it works?
No, it's a really, really precise timing circuit.
Yeah.
And so it figures out the, like the repetitive rate of the signal.
yeah.
And then just sort of indexes across it from one cycle to build up an
Oh, yeah,
image
yeah. So it
of
picks up,
the whole
it picks this
cycle.
one and then the next
Right, so, yeah.
The next wave, oh, yeah, okay.
1 pixel
Very good.
per wave is all it does.
Interesting.
1 pixel per wave, but the magic is in having a really stable trigger system and in having a really fast and accurate sample and hold circuit, which is all the magic that lives inside the expensive module here, right? And I think the jitter on the sample and hold and triggering is measured in the femtoseconds on this thing, so it's insane.
Yeah, because otherwise it wouldn't be a tens of gigahertz
Yeah.
device.
Now here's something, that's $60 on eBay. This is called a pulse modulator, so what you can do is you can feed it a constant sine wave input, and then you diddle this little TTL input up and down, and you get super sharp edges, like on the order of picoseconds. So you can generate very, very fast little pulses of signal. Okay, what this lets you do is if you're building an amp or some kind of circuit where you're afraid it might fry, when you apply tons of constant power to it because it'll overheat or something, you can give it 10 nanoseconds of signal, right? And even though your circuit's completely screwed up and it would explode normally, because it's 10 nanoseconds, you don't build up enough heat and everything is fine. Okay, so you can do those kinds of tricks with it. You can also use this for radar pulse generation, right? So if you just want to send a pulse out there and listen for reflections, this is an excellent way of generating a pulse from a constant signal source. And it's like $60, it's nothing. And then finally at the Puyallup flea market of all places, I found an atomic clock. So $80 later.
You just never know when you need one of those.
It was on the
You
second
just
floor.
never know when you need an atomic clock.
That's right.
But when you do, you really do.
Yeah. So yeah, I mean, the guy's like, yeah, it's atomic clock. Here's a GPS antenna. Yeah, rubidium source inside. $80. Okay, why not? So one of the neat things you can do with this is you can have synchronized receivers that are spread across the country, even since you're all synchronized to the same system. So that's kind of cool. But I just use it for synchronizing the clocks on all my lab gear. Anyway, that's the lab update. So those are the new capabilities. If you have any problems that might be helped by those capabilities, I'm open to helping fellow hams out. So if you have some circuits you want to debug or analyze, let me know, and we can throw them on the test bench and run whatever you want. All right. So this was upcoming work from last time I did this. This was a problem of too much crosstalk between our various sectors. This is still a problem, and we have tried to address this a little bit. Last year I worked on a little shield design like that. Then I discovered a new company that came on the market at a much more reasonable price than was available when I was doing the shielding work. And the price was so compelling, I just abandoned the shielding work, and this is what things look like now. Oh shoot, this is not the latest presentation.
It looks like my lamp in my.
It is
workshop.
that looks like
Yes, it looks like a fluorescent fixture.
that's probably what it is.
So this is just a waveguard shield. That's the company name across a ubiquity sector there. So this is on the Haystack site. Part of what I've been calling Generation 2 because it's actually using MIMO. Gen 1 was just single polarity, single channel. And it wasn't shielded, so it didn't work very well. In terms of the crosstalk between these, I can tell you we've had a great improvement. There doesn't seem to be any interference issue anymore. So this was a great success. Last year I was also looking at using these dishes, and this year on the Haystack site we're using those dishes. I had much better pictures for all of this provided by Tim that were saved to my Google Drive, and it didn't update for some reason. So
They have access to Google Drive.
Say, Bart, would you have more success in having to eliminate the interference between your panels if they were offset in elevation?
yeah, but so vertical offset is not always an option,
Okay.
right? We only get so much tower space,
Yeah.
right? Or we only get so much shack space. There isn't really a vertical offset option on a shack like this.
I see.
You get roof line and that's it. So we tried to do our best to put the metal siding of this building in between our various antennas.
Yeah.
So we've got 4 antennas and 4 corners, and we're trying to use the building as further isolation. And it seems to be working great. This is the inside view of that building where we installed all the power stuff. So this was purchased by HamWAN, this was purchased by HamWAN, that was purchased by HamWAN, and we did a bunch of cables and stuff as well. So these are the 2 charge controllers. This one is the main panels on the roof, and then This one's controlling the side panels on the side of the building that you can sort of see in this view. These are our side panels.
Oh, yeah.
There's also, we have a page on the HamWAN wiki. If you go into Puget Sound Data Ring and then click on the Haystack site, you can see much more graphic detail. All right, this was another thing I was looking at doing last year, doing some near-field sniffing of where the antennas were actually leaking and causing those interference issues using these little probes, but I never got around to doing this, so oh well. I can still do it though, just didn't do it. The next thing was doing some RF absorption so that we can, as well as shielding, if anything does happen to get into an antenna, we can absorb it, dissipate it as heat, and it doesn't go into the feed horn and into the radio, right? So again, more isolation work. So I did do some work in that regard. This was my little absorber test setup. You've got two horn antennas pointed at each other, and in between them you can place any kind of material. You can place a human hand, a glass of water, or some custom designed graphite-filled kind of substance, okay? And what this setup will do is, using that first instrument I showed you guys, is it'll simultaneously measure the amount of power getting through that material to the receiver antenna, which is good for knowing how much signal is blocked, but that's not sufficient for RF absorption. That just tells you that you've got a shield or an isolator. For absorption, you want the material to convert it to heat. So the second measurement it does is it measures how much signal bounces back from the material back into the original transmitting antenna here and going back to the instrument. So you can measure two of those things simultaneously. And if you've discovered a material that has no reflectivity and perfect absorption, then you've got yourself a great RF absorber. Okay? So I managed to produce some stuff that had pretty decent absorption, or sorry, pretty decent isolation, but the reflectivity was still pretty high. So I didn't really do very well on that front. It's kind of a complicated problem. You have to absorb electric fields and magnetic fields simultaneously, so you got to mix in some iron particles in there. I was just using graphite stuff. You've got to match like the impedance of free space properly, and that's a really tricky thing to do. You got to get your cell size right. You got to get your doping concentrations right. Yeah, it just kind of got out of hand. So
Maybe the guys at the Air Force have this down, I don't know.
there are companies that specialize in this, and that panel that I showed here, I mean, something like that, 1 square foot, you can pay hundreds of dollars for.
Yeah.
So yes, people are specialists and they have this down. They will milk you for it. So it's not in the ham budget to do it. That's why I was trying to homebrew it here, but it turns out it's kind of complicated.
There's probably no broad maker community in that one.
And I don't know if anybody's an EM expert or knows how to mix these things up or calculate the geometries here. So if you can derive some kind of feedback to let you know how you're doing on your design from the S parameters, that'd be great. And maybe you can tweak concentrations or whatever, but let me know if you know anything about this. All right, next thing I was looking at, again, to do with interference is filtering. So we've got these three sectors and they're all hearing each other. Well, what if we just put bandpass filters for each sector's channel, attach them to the antenna before the radio, and problem solved, right? They wouldn't hear each other and everything's great. The problem is the frequency that we're operating at, 6 gigahertz here, and the bandwidth that we're using, about 5 megahertz, is a very small filter bandwidth, 0.083% of the carrier. So it's very difficult to manufacture a filter like that. So I did manage to get some narrow filters configured, and I played with a couple of them, but the insertion loss was really high by the time that you've got that kind of sharp skirt going on. Okay, and they were the most horrendous things to tune. If you're off by like sub-millimeter margins, you're completely 50 meg over. You know, they're just horrendously difficult to tune. So I gave it several days. You know, I tried to tune them as best as I could. I had really great experience with a notch filter. It was a little 5-cavity notch filter. I measured the thing down to like 130 dB attenuation. Very easy to tune. So if we ever need to do notching, man, that's the way to go, because it's super easy to do. Insertion loss is almost nothing, and the skirts are super sharp and you can tune it easily. But bandpass filters, for whatever reason, much harder to tune and get working right. So that's where that stands. And I do have a little bit of an update coming up on that. Next thing I wanted to do was 3D field measurements of radiation patterns. So this is a double axis rotor. So I did get some of that down here, and I've got a little video. I don't know if I can play that for you guys here. Is that playing? Is this not going to play? Resume selection. How to remove buttons. Okay, well, I guess we're not going to play a video because PowerPoint's being awesome.
Do you have to use PowerPoint to play it, or isn't it exists as a file that you can just play directly?
I thought it embedded the file inside the PPT because the PPT is like 50 megs.
So it's not here on your computer at all? It's
I
just-
don't think it actually embedded it. I think it referenced it to a C drive on a different box. But anyways, this was just a video of some software controlling this rotor from a computer, and it does a little bit of a trick with controlling it because the controller is not very precise. It's a Yaesu thing, so you have to actually micro-step it a little bit. That's probably not the right word, but as you approach your target, you can start to hear the software slowing the thing down.
Yeah.
So you start intermittently, it kind of goes right until it settles on the right location. So that was all that demo was. The next step after controlling and rotating all of your antennas is actually making the full measurement and generating a nice field graph like this. So I did do some, Jesus, what the hell's going on with my presentation?
Like what we're talking about.
How is that? I'm on a totally different slide, PowerPoint. Try and keep up. What I love is it starts at the beginning every time.
There's a right click on the right symbol somewhere, and you can actually.
Oh, there you go. All right. So I wanted to generate these kinds of things for the antennas we were using so that I'd know in full three dimensions and really 4 dimensions, because these shapes can vary with frequency that you're using, exactly what we're pointing at where. And I did do some work on this aspect in addition to the stepper or to the rotor controller thing. I've got instrument control for the signal generator and the receivers, but I never quite pulled together the whole thing yet, so that's still kind of an open item. Next thing that was promised was this upcoming work of doing amplification at 6 gig. The thing is, I canceled that because if you have like interference issues, there's no sense generating more power because you'll just have bigger interference issues. So all of the work was focused on just eliminating interference and not raising power levels. That's the opposite of what we want right now. We're kind of at a plateau with our current technology in terms of the power levels we can run on a shared site. Yeah. Okay, final thing I wanted to do was experiment a little bit with radar technologies and bouncing things off of sites we can't get access to. So like shooting things at a tower and seeing how well it scatters on the other side or forwards or whatever other directions. So I had an experiment that was getting set up with Kenny's location there because he's got a pretty good line of sight to a tower. Sadly, an amplifier died before I got the experiment to Kenny's place, so whoops.
Not my fault.
But it wasn't a total loss. I did manage to generate some radar pulses here. So the top one is 6 gigahertz, the bottom one is 2 gigahertz, I believe. And if you look at the seconds per division, this is 1 nanosecond per division of the oscilloscope here. So from this marker to that marker is 7 nanoseconds here. So this, I'm going to call that the end of the pulse. There's a little bit of a trailing oscillation, but I'm going to call that the end. So this is roughly a 7 nanosecond pulse, being sent through space. If you do some math on like speed of light, this ends up being something you can hold. It's very short. It's not a long, infinite thing. It's actually you're playing with a couple feet of stuff. It's kind of cool. So, and since my amplifier died, I might have overcompensated a bit and bought like a 3.4 kilowatt Klystron amplifier instead. In retrospect, that might have been a bad idea because it's really difficult to work with those power levels. You can't even find like dummy loads. Like try finding a 4 kilowatt dummy load on waveguide. You can't even tune the thing, so it's.
You can run legal max on Wi-Fi at 5.8 gigahertz.
You know where I was going.
Yeah, you're shut down Wi-Fi in Seattle.
Yeah, this would really
You can Wi-Fi see
be really popular.
And 3.4 kilowatts is not that expensive. This was $50 on eBay when I bought it.
What about the power supply for it?
Oh, that was a great story. Power supply. Let's not go there. I still need to build a power supply for this.
So what does it need as an input?
It takes on the order of milliwatts.
Oh, really? It's that much
Yeah,
amplification?
I think it's like 50 millis.
Wow.
I think it's 36 dB gain or something.
Okay.
Yeah, it's really beefy. Klystrons are
So that's
insane.
much better than your normal ham amp, which needs like 100 or 200 watts of input to get.
Just
Yeah.
exactly.
Yeah,
Watt
this is a lot of gain in a very resonant chamber.
What did that come out, you know?
These?
Yeah.
I have no idea.
Stolen from military aircraft.
I was gonna say, in the military, we didn't have, ours were 2.5 kilowatts.
Okay.
And they called them the illuminators for
Yeah.
whatever reason.
Oh, and I should point out, these aren't pulse ratings, these are CW ratings.
What?
Yeah.
Wow.
So you can continuously 3.4 kilowatt.
Yeah,
They
sure.
make others that are much higher power rated, but you can only pulse them because they're meant for radar emission. But yeah, I don't know. This was by like JetSat satellite service, so I'm guessing like uplinks to geostationary things, video, data, whatever.
Yeah, that makes it understandable that dummy loads are an issue, especially dummy load you get to use twice.
Yeah, you need liquid cooled dummy loads at these power levels. There are some out there, but
People you don't like.
I was gonna say, you know, your dummy load is your neighbor's garage door, right?
Exactly.
you could get a horn antenna and just shoot it out into space. Yeah, you could do that. That is definitely an option. That's probably actually what I'll end up doing. I do want to do an EME with that thing though. That'd be awesome. At 6 gig. Anyway, a little bit of a personal note since we're talking about upcoming work. So this is a loop antenna I've been working on. It's got 2 capacitors inside the control box there. One is a split capacitor and the other one's just a standard varicap. So the way that you couple coax into this loop, there's no magnetic coupling whatsoever. It's all like direct electric field through these capacitors. So it's kind of neat. I like it. So I'm working on a way to turn these capacitors because they're mounted outside. So I want to be able to tune these things from inside. So just the other day I finished the PCB layout for the controller for this. So it's got 2 really nice encoder knobs. I bought giant knobs at Vetco there. So those will go on the encoders. The encoders are incredibly expensive. They're like $24 a piece. I never knew encoders could be so pricey.
At Vetco.
No, not at Vetco. No. These are the cheapest I could find online for 64 pulse encoders.
Are those for H bridges?
Yeah. I don't think these are H bridges, but they are H's, yes. They're L293DD chips, in case you're wondering. So they're just drivers.
So shaft encoders that we're talking about, the $24?
Yeah, shaft encoders.
Okay.
Yeah, just so you have 2 very finely controlled knobs you can play with and adjust
Yeah.
those caps by hand. Eventually, you probably want to computerize it, but I do want to keep it real for the beginning anyways. So that's upcoming personal work. As soon as that's done, I'll move on to some other HamWAN stuff. So this is the specific HamWAN stuff I want to move on to. So a couple of radios are on the market that are kind of interesting, especially in the light of the problems throughout the summer with 6 gig coverage. We need something that penetrates through trees, especially in the Northwest. Other areas may not have this problem, but we certainly have it in spades. We've got 100-foot pines all over the place. So I'd like to try using 902. And I think I talked to you about maybe trying an experiment on 902. It's the lowest frequency band that doesn't have those symbol rate limits, it doesn't have bandwidth emission limits, so it's the lowest feasible one where we can still get some decent speed. And to what you were talking about earlier, this would be a 902 example where we can use OFDM, we can pack multiple bits per hertz in this example. So I'm not sure which one of these 2 radios we'll end up using, but the thing is the power levels on these still don't fill me with a lot of confidence. So since I would really like to have a service that has deep penetration, maybe be able to use mobile, slap one of these things with a little vertical or a couple of verticals on your mobile, and you might be able to roam around. The filter story is a lot easier. 5 megahertz at 915 is only 0.5%, right?
Mm-hmm.
That's in the realm of implementable, right? If you've ever done filter design, 0.5% is usually where the generally available filters stop. That's their tightest spec, but it is generally available to have a 0.5% filter. But I really would like to increase their power beyond the 250 millis or 500 millis. So I'd like to get some kind of bidirectional linear amplifier because these do use amplitude modulation. And it's got to have really fast TR switching times on the order of a microsecond. Okay, because that's what these signals expect.
What are those things barefoot?
Barefoot, they're in the milliwatts. So,
Weird.
yeah, I know. And I'm sure they'll still work to some extent on barefoot. I would feel much better if I had a high power option, right? And maybe we could do a high power option on our sites, and then it's up to you whether or not you want to do high power option downstairs. So I started research on creating such an amp, and I don't have time to get into the details of it, but it's kind of interesting, and it's a lot more than just a gain block. You have to do a ton of control circuitry around it. We've done some 900 megahertz propagation testing. I think we did like one test, and it went through trees. We need to do far more to get some real numbers, though. It's very hard to find attenuation data through foliage. Like, the models through like atmosphere and all that, everybody's got, but as soon as you start asking questions about trees, pines versus evergreens, right? There's almost no data on it that I was able to find. So we need to derive some, and that's what we're doing. Since we're locked pretty much to 5 meg channels because there's so little spectrum on this band, it would be good to use MIMO just to get our efficiency up. But
Those devices, they support that?
one of them does. This one has 2 antenna ports. This one does not. This one we'd have to redo a bunch of the software config, so it's more work in that regard. This one we'd copy and paste, and it's perfect compatibility with the rest of HamWAN. So there's some trade-offs there. And MIMO, in terms of the mobile case, I don't know if that's going to help us as much, but maybe there's some horizontal, vertical thing. You can also do spatial. I don't know if we're going to run multiple like vertical streams or not. We'll have to have a look at it, but that's what's on the table right now. All right, and in terms of what we need help with, executing on Tequila, I think, is important. We need some insurance to be gotten, some contracts to be signed and returned. We need purchasing of equipment, installation, config, so muscle and general aid there. I think we need to do some trademark registration. So someone decided they like the name HamWAN, so they want to use it for their own HamWAN things that are non-HamWAN actually. Yeah, just like hammy microwave networks, but not really HamWAN compliant. So they dumped a bunch of money on HamWAN.com, buying it from squatters, and I haven't seen any. Huh?
And now they're squatting.
They're not squatting.
using
They want to use it. I haven't seen any content on there yet, but it's kind of a trademark infringement as far as I'm concerned. So I just like to get that federally registered. Huh?
You have a trademark.
No, we don't have one registered.
No, well, then it's not an infringement.
No, this gets a little complicated. So you can have a trademark just by using your mark in trade.
Yeah, but you have to
Right.
get it registered. in order
You don't
to
have
sue
to get it registered to sue someone. You
Oh,
can
really?
always take them to court and have your case and say, hey, they're infringing on our business. If you have it federally registered, it just makes your case a lot easier to process through the system. So that's why I'd like to go through the registration and just not have to deal with the details of it. We need some extra help on network administration. So there's things that are broken all the time. And we need some root cause analysis. We need some fixes to go out there to make sure those breaks never happen again. We just don't have the manpower to do that right now. So if you know anyone who are willing to help yourself. And since this isn't the latest version of the presentation, there are a few things missing from here. So in terms of achievements from year 2, we've also got a user portal that was brought up so people can self-service their own HamWAN config. You can define your DNS names. I don't know if we can do IP address range registration yet or not, but that'll just grow over time. So that's a really good one. And I feel like I'm forgetting something because I don't have all my slides here. And of course, there's the standard things that we need help on, like money, very important. Sites, probably more important than money. And just general, muscle. Going up mountains and deploying things is very sweaty work. So that's kind of the plan. I don't have a very large plan, certainly not as expensive as last year.
Hey, MicroHams, anybody monitoring?
Yes, we are.
This is K4PNG. What do you need?
Access to the building, thank you.
All right. Well, that's as good a note as I need to end it.